This is one of two COVID simulations you will use to explore the spread of an infection in a population of 500 people. You'll need to initialize the model before running it by pressing this Setup button. The initial population will be distributed across households of different sizes. Households are represented as small gray squares. Circles with black dots in the center of them represent students. Those with no black dots represent adults. You can change the number of initial students in the population by adjusting the value of this slider. You'll need to press Setup again after making these changes in order for them to take effect. When you press Go Pause, time will start to elapse in the simulation. These two monitors help you keep track of the number of days that have elapsed and the number of hours in that day. There are only 12 hours per day in this simulation rather than 24, in order to help speed up the simulation results by skipping over the part of the day where many people are either sleeping and or no longer traveling into and out of other places in their community. During the 12 hours a day that are being simulated for this model run, we can see students traveling to school during hour 1, remaining at school for 8 hours, and then traveling back to their household after that. You'll see this repeat for 5 days in a row, and then students will not travel to school for 2 days in a row. The 7-day pattern will repeat to simulate a typical week of the school year. As students move to school, you'll see a gray dot appear in the household they left from. This represents a spot in the household where they live that they'll return to occupy at the end of the day. You may be able to see the movement of a single student over time more clearly by pressing this Watch a New Student button. Each time you press it, the simulation randomly selects a new student to watch. Pressing this button resets the view. Let's get ready to run the model once with some infected people in it. To do that, we'll need to make some changes and press Setup again. So let's first pause the model using this button, so we can see what those changes are, and so that the model doesn't immediately start running again after we press Setup. You can adjust the number of initial infected people using this slider. And you can adjust the model run so it'll automatically stop when it reaches a certain point. Let's change that using this menu so that it'll automatically stop when there are 0 infections left in the population. You'll need to press Setup in order for these changes to take effect. And notice when I did that, the color of 5 people either turned pink or red, indicating they are infected. Red showing that they're symptomatic, pink showing that they're asymptomatic. All of these initial infections are assumed to be in day 1 through 3 of the 14-day period it takes for the infection to end for each person. People who are symptomatic will start to stay home until the end of the infection on day 3 of their infection. Let's press Go Pause now to run the model to watch what happens over time. At the end of the infection period, one of two things may happen to a person. They may turn green, indicating they have recovered and are now immune to the infection. Or they may die, in which case an X will appear on their spot in their home. There's a 3.6% chance that the infected person will die rather than recover from the infection. This is the average mortality rate reported for COVID-19 infections as of August 2020. In the simulation, infections can only be transmitted from one person to another within a place, such as a home or school. They cannot be transmitted when a person is moving between places, and they cannot be transmitted across black line boundary lines between places. The default chance of spreading the disease to another person within a place are 0.5% per hour. So, more time in contact increases the chances of transmission. Other things, such as mitigation strategies, including wearing masks in a place and others, will reduce those chances of transmission. The default setting for the schooling plan is such that all students are attending school in person and there is no requirement to wear masks. You can change the schooling plan at any time the model's running. Those changes will take effect the following day in the simulation. To fast forward time, you can adjust this model speed slider to the right. Adjusting it to the center or to the left will slow it down. The center point indicates the standard rate at which the simulation time goes by. These monitors below provide important information about the number of people who haven't been infected yet, total cases so far, the maximum daily cases, and the number of deaths. Each death will be graphed on the graph as a single vertical line to mark the day that it occurred. Let's watch for that now. The other two graphs indicate the number of infected and recovered people. Pay attention to the shape of the graph, particularly on how the effects that you are having on the shape of the graph are due to the changes that you are making in the simulation. Are you making changes that are affecting the flattening of the curve of the graph? Doing multiple model runs for any given set of conditions can help you determine whether those changes are having that effect. The simulation run will automatically stop when there are 0 infections. Let's watch that happen now. You might find it useful to stop the simulation when there are 0 infections, but you also might find it useful to compare the graphs between 2 model runs when each model run is set to run for the same amount of time. You can do that by adjusting the auto stop condition to any of the other values listed here. You can read additional data from the graph by hovering your cursor over any point on the graph. But since there are 3 different things being plotted, you may want to turn off one of the or the other of the graphs by clicking on that particular label on the bottom of the graph. Notice that I've turned off deaths and the number recovered, so I just see the number that are infected. I'm going to pause the model now and hover over the graph. And notice that I can determine things like what happened on day 16. There were 44 infected people in the population. Since every time you press setup, you're going to get a different household selected for where infections occur and where there is an element of chance also for whether the infection spreads between people in any given place, you may want to run multiple model runs to test what the outcomes are in general across multiple trials before changing other variables in the simulation.